Hello, it's Chandler Klebs here, and I have another programming video. Now, my last video I tried to record, I changed it to unlisted because something went horribly wrong. It looked like it was recording properly while I was recording it based on the preview window, but no, something happened. It was just showing my camera the whole time and was not showing in the video the stuff that I was actually talking about. I was showing my desktop. So hopefully it will work this time, and I really hope so, because I've been working hard on these functions I've been writing, and they're a big deal to me, although other people may not care so much about it. So anyway, I'm going to switch to my display capture here. So hopefully it will show you my desktop. There's OBS. Okay, so now I'm going to go to my source code I have here. Okay. So I have my main.c file. This is my main source file for where the main function is, and that's where most of the magic happens in C programs. So okay, first of all, let me show you what it does when I run this. Okay, first of all, I'm going to run the command here that compiles and runs this program all at once. And what it does when I just do the command to compile it and run it in one command, it has a string 1 followed by 4 zeros, and it says the base is 2, and then it displays the number based on that string in multiple bases: binary, octal, decimal, and hexadecimal. And in all of these bases, it represents the number 16. That's what it represents. That's because the base is 2. And so that 1 followed by 4 zeros equals 16 in binary. However, here's where it gets interesting. And also see at the bottom there, it shows the format flags that display in octal, decimal, hexadecimal according to printf. So that's the output. I'll get into why it outputs that later. But first, let's try running the main program by itself. It does the same thing. But if I do the main program, and now let's say that I do something really funky, like let's say I do 10101. Okay, let's try it with that. Then it actually equals decimal of 21. That's because of 16 plus 4 plus 1. If you know the binary numeral system, it makes sense. So it's decimal 21, or 1, 5 in hex, because 16 plus 5 is 21. So it does different things based on the number of arguments, but we can change the base too. So if we change the base, let's put the base as 1010. I programmed this to do binary. So now it does 10101 in decimal. We've changed the base to decimal just by inputting numbers as command line arguments. It's really impressive how this works. Okay, so this means I can enter any sort of number. Like I can enter 987654321. Let's see what it does. Yep, it works. However, here's what's interesting. There is a limit to how high the numbers can go. There actually is. And that's because of the fact that it's using a 32-bit integer. And it just so happens that the long data type for this particular compiler I'm using is only 32 bits of an integer. So sure, that's kind of a limit, but anyway, it proves how this program works. But let's suppose that we just add some more digits. Let's see what it does. Yeah, let's see here. Well, it's already showing weird stuff. Yeah, you see, it's already. Yeah, it doesn't seem like it crashes the program. No, it doesn't crash it. It just doesn't know how to handle it when there's that many digits, because it's trying to extract it. It may not make sense why it works, but I will explain how this works. Let's take a look at the source code. And see, there's these conditional statements based on the number of arguments. If argument equals 1, meaning that only the name of the program is run, but there's no extra arguments, it has a default setting, and it calls ulong test. And it starts using the command line arguments according to those rules that I set up. So here's the deal. There are, in the file ulonglib.h, which is included here, I have 3 functions. This function here is L to string, or L to str. Now this one is a special little routine I wrote that will take an unsigned long integer. Whatever integer you pass into it becomes an unsigned long integer. I do unsigned integers because I like them more and because they're easier to work with. And the exact method by which it works might not make sense, but basically it does a division to extract the digits based on the base. But then it has to do some special math if the if the base is less than 10. If there's a digit that's less than 10, it'll just add 0 to it, the character, to make it look correct. Otherwise, it will add a capital A to it. When you understand the ASCII character set, you'll understand exactly why this works. It's just a shorthand I learned from reading the C programming language. So anyway, and I have comments in this. And like this static array is actually used by the L to string function because it's just a temporary storage area where the characters are stored, and it returns a pointer to the string right after the proper number of characters have been added to it. So it's a little bit weird. And it also, it does some incredible stuff. It also can do things based on a customized width. It certainly needs some more work, but, well, I mean, it works fine, but there's some minor improvements I could do to make the source code look prettier, which I may eventually get to. So anyway, it works, and as you could see, it displayed the results properly. Now this one is the string to long function. This function right here is the function which processes the command line arguments, and it can take any string of digits and interpret them as different characters. But as you see, there's a lot of code in this function, and that's because when you're converting a string into an integer, there are several factors you have to keep track of. First of all, you have to have a pointer to that character string, which is a byte string terminated by 0. And then you have to have a base. What base is this? Is somebody putting a number in binary, decimal, octal, hexadecimal, or is it base 3 or base 6 or base 5 or something? And it can handle any base that's from 2 to 36. But as you see, I put a conditional statement that will print an error message if their base is outside of that range, because otherwise the program just freaks out and will give you gibberish. It'll give you complete nonsense. And then I have a little loop that gets rid of any white space at the beginning of the string, any invisible characters. And then it does a very complicated method. It goes through each element of that array. It actually uses a pointer and increments the pointer to keep going to the next one. And then it tests the character for each possible combination. Is it within the range of the digit characters, or is it a capital letter, or is it a lowercase letter, or is it a white space character? And so it does all these conditions. It does all this all this subtraction and addition, and like, for example, return L. L is the name of the long integer, and it just returns it like if it encounters a white space, or if it encounters something that's not an alphanumeric character. It's neither a digit nor an alphabet letter, or if it is valid of those but it's not a valid character for that base, then it will start printing that error message. So I understand how it works. I mean, I wrote it and everything, but it's still just a little bit weird for most people to understand it. But I don't know. Anyway, it certainly works, as you can see. Anyway, and then oolong test, this is just another function which is written for only one purpose, and that purpose was to test how well the other functions work. And what's interesting is that this right here, it does several things. It has a long integer named L, and it sets a width variable to be 8 times the size in bytes of that variable. So that's how it displays 32 bits, because the long integer is apparently 4 bytes in size and there's 8 bits in the byte. So that's why I did it that way. However, it's possible to go beyond that. For example, if we were to set width equal to, let's say we set it to, let's set it to 20. Okay, let's just set the width to 20 temporarily. And then let's just try running this program. So let's see here. I need to recompile it. Okay. Right, okay, let's go back. So what we have there is, notice that now it displays 20 digits. It's showing the default how it works, but it's showing only 20 digits. I can make it show only 10 digits if I wish. Yep. In fact, I can even make it show 1,000 digits, which won't actually do anything. It's completely useless. But it just displays a whole bunch of extra zeros. But anyway, the reason that it accepts a width argument is because when I like to display numbers, I like to see them lined up. It's my personal preference why I did it this particular way. And then you'll see that in how each of this works, it displays the string, it displays what the base is. It displays the base in decimal just because that's what most people are used to. And this is what gets that string and turns it into an integer. That string to long function is called, and it uses the command line arguments, or it uses the default if no extra arguments are given. So anyway, it displays that number in binary, octal, decimal, and hexadecimal. And see, it uses printf statements for output, which is very convenient. And it calls that function L to string to return the string so that printf knows what to print. It works, but then notice this part here, these printf statements display that long integer just using printf format flags. And I did that because that helps show that the result is what expected, because my program should print the identical output as printf would, at least for octal, decimal, and hexadecimal. Except with one little minor difference. My program only interprets numbers as being, it only interprets them as being unsigned. So what happens if we decide to put a negative number? Okay, how about let's add a temporary extra line. Let's set L equal to -1. What happens when we do that? That way it's going to completely ignore whatever the string is. Okay, let me make sure I've saved these files. Then let's compile and rerun. See what it does? Then it displays what -1, how it would be represented in a 32-bit integer in these 4 bases. And it's very odd because it does indeed show you this identical output for the octal and hexadecimal equivalents, but it shows you that it's -1 using the LD flag for the long decimal integer flag using printf. So that shows that it's working right, except that my program interprets it as unsigned instead of signed. And the truth is, that has a lot to do with the fact that I made sure that in the L to string function, it's defined as an unsigned long int. So, or long, it's an unsigned long integer, whatever. So, but the funny thing is, here's the thing. If we make it signed in that function, it doesn't make any sense. It doesn't show you anything. And that has a lot to do with the fact that my algorithm doesn't exactly work with signed integers. So it makes sense with unsigned long integers. So, and I like that because it's simple. I could write something for signed integers if I really wanted to, but who cares? You can use printf for that, because most people just use printf if they just want decimal integers being signed or unsigned. But mine was more of showing off about displaying things in binary. Plus it can do all the other bases that people don't even use. So anyway, that's basically how this thing works. Okay, and I'll get rid of this extra temporary line I put in here. So yeah, so that's the thing is, okay, there it is. So yeah, we can do all sorts of nonsense. I can do 101100. Yep, I just did the decimal number 40. Yeah, I can mess around in binary. I can change the base to hexadecimal. Yeah, I can do some crazy stuff. So I just wrote an interesting converter that can convert my strings of text based on what I input. Now it may not be all that useful, but it actually has some profound implications. Because if somebody is writing something and they want to output a number in a base other than the standard decimal, octal, or hexadecimal that the printf function in the C standard library allows, my functions make it possible. So, and I even have thought of doing more functions. Like I have ideas about future functions I could write, such as a function that doesn't even use printf, but perhaps it uses it uses putchar, or it uses fwrite, or some other C standard library function to display it and bypass printf entirely. Not sure why I would do it, except just for the fun of it. But anyway, these functions are actually useful for their own purposes, and if I got requests to make something that could handle a signed integer as well, displaying a minus sign, I suppose I could probably make it work, but I'm not sure if it's worth it. Plus I might have to figure out how to do it. It might take longer to do. But anyway, I hope that this video has worked out well. Oh, and actually, there is one more thing I want to show you. Let's close this. Now, if you look at my path here, you're going to notice something. This is just a command.exe thing, and it's actually very interesting. And see, it uses like DOS style commands and everything. So yeah, main and stuff like that. And this isn't actually Unix. It's actually, you know, it's actually like DOS Windows type commands. So it's very different than Unix. But notice my path is Unix, source, C, ulonglib, all that. Well, see, there's a reason why this works. And if I type path, it shows that my path is c/unix/mingwei64/bin. And there's a reason for this. And I'll show you this. See, I have a shortcut on my desktop to this folder. And this file, like, what this does, start.bat, it starts my own little thing. It sets my path to that so that I can run GCC and I can compile all my programs. And it's actually very interesting because so what you see here is this mingw64. In here is the system of compilers. I think it's called Minimalist New for Windows, and this is the 64-bit edition. Not sure why my long integers are still 32 bits, but that's just a weird thing. And it has more than one version of GCC. That's one thing I'm not too sure about. Like, yeah, I'm still trying to figure this out. In fact, I do have one more test to run. Okay, let's go back to, I wish I hadn't closed this because now I have to get back to source C ulonglib. Oh, and by the way, the reason it's called ulonglib is because it deals with unsigned long integers. That's why it's that way. So let's try something. So let's look. There's a different version of GCC here. Let's see what this one does. So I'm going to copy paste that. Let's see, when I run that, yeah, it shows no input file. So let's try compiling. Hey, I wonder what happens if I do ulonglib.h and compile it directly. Yep, no, it doesn't work when I try it that way. Okay, so anyway, yeah, enough of that. Let's try main.c. So let's compile it, and then let's see what happens. Oh, yeah, see, there's main.exe, which is the file that was already there, but there's a.exe because I did not specify the name for it. And they behave identically. They do the exact same thing. So I'm not really sure what the difference actually is. I think they're totally identical. How weird is that? I don't know what I'm doing. I actually don't know much about the MinGW compiler, but it is the compiler I use. I have another compiler as well. I've used Cygwin before, and I'll show you that. Like, I have my Cygwin 64 environment, and it has some old stuff in here. I have some stuff. I had it set up with a custom prompt and everything, but and I've made backups of the source in here. But the source I'm working on now is actually done. See, this is like a little Unix emulation type of environment. So you can run ls, you can run cat, you can do all sorts of interesting things. So I was using that, and it does work fine, but the reason I started switching to this other environment with the Windows command prompt was just because I wanted to see if it was possible. But anyway, that's probably enough of a rant for now. Yeah, okay, I'm going to delete those extra executable files, and wait, what is this file? I'm trying to figure out what this file is. I don't even know what in the world that file is or how it appeared. Okay, I'm going to delete that. Well, anyway, I'm going to end this video, so hope that somebody got something out of this little programming rant. But it lets me show that my source code works, and it provides me a backup having this video, even if I lose the source code. But I try not to. I make extensive backups on my Dropbox account and by emailing it to myself. But if I keep working on these functions, which allow me to display numbers in the bases I want, I could then incorporate these into larger programs, assuming I ever got skilled enough to do larger programs, so that I could display these numbers in various bases. And a long time ago, I used to use the GMP library to do multi-precision integers, you know, integers for millions of digits and that kind of thing. And I could learn how to do it again theoretically, but the setup is a lot harder on Windows than it is on Unix. So whatever, I may figure that out eventually. Well, we'll see. Bye.